Okay, so in today's video we're going to have a look at error intervals. We're going to have a look at some decimal place rounding, some significant figure rounding and some other little bits of rounding as well. But grab a piece of paper, grab a pen, make some notes, and we're going to kickstart with this question. Now there's quite a good little trick for all of these little questions, so I'll explain it a little bit in this first one, but then we are just going to be applying a little bit of a trick for the rest of them because they are quite nice and simple once you've got the hang of these. But having a look at this one, it says 32.7 has been rounded to one decimal place right down the error interval. So the error interval just means essentially if it has been rounded to one decimal place, what's the biggest and what's the smallest that number actually could have been. We refer to that, we use the language upper and lower bound. Okay, so we're going to have a look at what the upper and lower bound is. Essentially what's the upper bound is the biggest number it could have been, and the lower bound is the lowest number it could have been as well. So thinking about the number 32.7, and I'm only going to do this for this one question, but if we think about a little number line, if I just imagine a number line, and here's 32.7 on my number line. Now the next one decimal place value above and below would be 32.8 and 32.6. Now thinking about this, if the number rounded to 32.7, then it could only be within these little sections here. It could be halfway between 32.6 and 32.7, or it could have been, and we'll talk about the upper bound, halfway between 32.7 and 32.8. Now those numbers in between 32.6 and 32.7 is 32.65, and in between 32.7 and 32.8 is 32.75. Okay, and it can sometimes help just adding a naught onto the end of these if it helps to sort of visualise that. So we can say in between 32.60 and 32.70 is 32.65. That can just help just to sort of visualise it a little bit better. Now in terms of the upper and lower bound, it could have been this number here, 32.65. Now 32.65, if we round that to one decimal place, does round to 32.7 or 32.70. But if you think about 32.75, this one here, it can't actually be that number, can it? Because that would round to 32.8. Think about our rules of rounding there. That 5 at the end would round it up to 32.8. Okay, but we're going to incorporate that into our error interval. So when we write our error interval, and it's going to be these two numbers here, okay, this one here is called our lower bound, and the upper one there is called our upper bound. Okay, but when we put this into our error interval, we're going to incorporate the fact that it couldn't actually be equal to that upper bound there. Now when we write our error interval, it looks a very specific way. We put something in the middle. We can either put 32.7 or we can just put a letter in the middle. I'm just going to put the letter X in the middle. We have two arrows pointing to the left for our inequality here. This is how we write it. And we put our lower bound on the left and our upper bound on the right. So our lower bound on the left, signifying our lower number, is 32.65. And our upper bound on the right is 32.75. Now we just spoke about the fact that it can be equal to 31.65. So on our inequality for that one, we put the equal to symbol underneath the inequality there. But it can't be equal to 32.75, so we don't have a little equal to symbol on that inequality. So that right there is our final answer. And that means, as an inequality, it means that our number for 32.7 has to be somewhere in between 32.65 and 32.75. But it can be equal to 32.65, but it cannot be equal to 32.75. It's got to be less than that, because as soon as it hits 75, it would round up. Now that's the logic behind why we write the inequality the way we do, why we write this error interval like that. But there is just a nice little trick. Now if you look at this original number, 32.7, to get the upper bound, the only thing that's changed is this extra 5 on the end. And that's going to always be the case for these ones. All you have to do is put a 5 on the end. And then if you look at the lower bound, again there's a 5 on the end, just here, but the 7 has dropped down to a 6. So when I'm doing these, and I'm going to do it on the next ones, I straight away find the upper bound, I just stick a 5 on the end, so 32.75, and then I also then do the lower bound, and I drop the 7 down by 1, or whatever number's at the end there, drop it down by 1, and again just stick a 5 on the end. So I'm going to do that on the next question, but there's a bit of an explanation as to why we do it the way we do. But once you've got your head around this concept here of just sticking a 5 on the end and then dropping it down for the lower bound with a 5, you can actually do these pretty quick. You've just got to remember the way that the arrows point both to the left. You can always think about a little song there that might remind you to always put them to the left, and then the equal to symbol always goes on a lower bound there. Just thinking about the logic behind why it can be equal to that one, it can't be equal to the upper one. Okay, let's have a look at another question. Okay, so 0.34 has been rounded to 2 decimal places, right down the error interval. Now again, I'm just going to put an X in the middle, and I'm going to put my arrows pointing left. We know that this one's going to have our equal to symbol on it. I just need to find, and I'm going to label it upper bound for U as UB and lower bound as LB, and I use this quite a lot. So to get our upper bound, which is the one I always start with, all I'm going to do is I'm going to stick a 5 after the 4 there. So it's 0.345, and there we go, there's our upper bound done. Now to get our lower bound, we just need to drop the 4 down to a 3, the last number there up in the 0.34, so it's 0.33, dropping it down, and then again stick a 5 on the end. And there you go, that is your error interval done. So it's 0.335 and 0.345. Okay, and that's your final answer, and there's your error interval done. Let's have a look at one more. So 2.56 has been rounded to 3 significant figures, right down the error interval. So it's also been rounded there, look, 3 significant figures in this case is 2 decimal places. And I always think when it says significant figures and it's been rounded, I think, well, how else could I describe that way of rounding this number? So 2.56, that's to 2 decimal places. So this is exactly the same as the previous one here where it said 2 decimal places. Okay, but it's been given to us as significant figures, but it could have actually been given either way. So again, right down the error interval, we're going to treat it in the same way. So I'm going to put something in the middle, and you don't always have to have a letter in the middle. I actually could just put 2.56 in the middle. So let's do it this time with 2.56 in the middle. You wouldn't be right or wrong, wrong to do it either way. And then everything else stays the same. So again, getting our upper bound, I just stick a 5 on the end. So 2.565. And then for a lower bound, that's 6 there. It's going to drop down to a 5. And again, just stick a 5 on the end. So 2.55, and then again stick a 5 on the end, so 2.555. There we go. So there's your little trick for doing upper and lower bounds as an error interval. Okay, stick a 5 on the end for the upper bound, and then drop that last number down, and again just stick a 5 on the end for the lower bound. Okay, here's some for you to have a go at. Okay, so here's 4 questions. So pause the video there, have a go, we'll go over the answers in a sec. Okay, so it doesn't matter what you've put in the middle here. I'm just going to put X in the middle for all of these because it just keeps it all looking consistent here. So the upper bound is 2.45 and the lower bound is 2.35. Onto the one below. Let's have a look. We've got 6.8515, and the next one 6.851 down to a 0. Stick a 5 on the end. And there's that one. On to the next one. Okay, so 51.045 on the end, and then 51.0, drop the 4 down to a 3, 5 on the end. And then the one below, let's have a look, last one here, 0.8435 on the end, and 0.84, drop it down to a 2, 5 on the end. There we go, you can kind of see there's a massive pattern that appears on obviously when we've got decimals involved. Let's have a look at some where there's no decimals on the end. Okay, so here's this one. 340 has been rounded to 2 significant figures right down the error interval. Now again, when it comes to these significant figure ones, 2 significant figures in this case could have been described in a different way again. So not in terms of decimal places this time, but if you look at the number 340, that has been rounded to the nearest 10. Okay, so it's been rounded to the nearest 10, and just thinking about it like that can actually help in this case. So I'm just going to write here nearest 10. That's the other way that we could have described 2 significant figures. Now again, there is a little trick here. We'll think about the logic behind it, but in terms of the nearest 10, well, if we think about a little number line again, I'm not going to do this for any others, but if we think about a little number line, 340, 350 would be the next nearest 10, and 330 would be the next nearest 10 below. And in between those, again for our lower bound and our upper bound, it'd be 335 in between 330 and 340, and it'd be 345 in between the upper bounds there, okay, the 340 and the 350. So in terms of actually getting these, I mean, that is our lower and upper bound there. We've got 335 and 345, but thinking about the little trick, if it's to the nearest 10, that means it could be 5 above and 5 below. And the little trick for this one, it's just the first 0 that you see, that is going to become our 5 this time. Rather than just sticking a 5 at the end, it's our 0. So if I put 340 in the middle, okay, and I'll just show you what I mean here. So in terms of the upper bound, which I always do first, the first 0 in this case is what becomes our 5. So it's 345. And then the same process as before, the number before that drops down, so the 4 drops down to a 3, so 330, and stick a 5 on the end, so 335. Okay, and you can see that from our number line, but I'm just thinking about how you can do these nice and quick without fully drawing out a number line. Okay, so it's been rounded to the nearest 10. When it's significant figures and there's no decimals involved, there's a slightly different trick here. So the first 0 turns into the 5 for the upper bound, and then same process again, drop the number before it down and add a 5 on. Let's have a look at another one. Okay, so without drawing a number line here, we've got 64,500 that's been rounded to 3 significant figures. I'm thinking about what this has actually been rounded to. Look, it's 500 at the end there, 64,500. So that's to the nearest 100. Nearest 100. There you go. And if it's to the nearest 100, we're looking at 50 above and 50 below. So in terms of actually looking at our little trick here, look, 64,500 in the middle. The first 0 is this one, which represents our tens digit, which if we turn it into a 5 is going to become 50. And that's why this little trick works, that first 0. So let's turn that into a 5. So 64,550 is our upper bound. And then the same process again, I'm going to drop the number before that down by 1. So I'm going to drop the 5 down by 1 and then just stick 50 on the end again with it. So that'll be 64,400. And then again, turn that into a 5, so 450. And there you go, there is your upper and lower bound here when it's to significant figures. And in that case, it was the nearest 100. But you just find the first 0, turn it into a 5 for the upper bound, and then drop it down by that amount for the one below. You can always think, for the upper bound, look, we added on 50, it became 550. So for the lower bound, you just have to take that same amount away. So you take away 50 from 500, and you get 450 at the end there for that one. Okay, right, here's some for you to have a go at. Okay, so there's 2 questions there. So pause the video, have a go. We'll go over the answer in a sec. Okay, so for the first one, I'm going to put X in the middle again for these. You can put the number in the middle, not a problem. So for the upper bound, that 0 at the end there is going to turn into a 5. So 3,455. And if we take 5 away, or drop the 5 down to a 4 and add the 5 on, or take 5 away from 50, we get 3,445. There we go, and there's our final answer for that one. 3,445 and 3,455. On to the next one. The first 0 there is after the 4. So our upper bound, which is the one I always do first, 2,450. And for the lower bound, if we take 50 off, that'll be 2,350. Dropping that 4 down to a 3, and again just sticking that 5 in that first 0's place. And there we go, there's our 2 answers. Right, let's have a look at something else. Okay, so it says the length of a railway line is 2,400 metres to the nearest 5 metres. Write down the error interval for the length of the railway line. Now this is the one unique scenario really when it comes to rounding, because if we're rounding to the nearest 5 metres or the nearest 5, that just throws it up a little bit. And if we have a look at a number line again, if it's to the nearest 5, 2,400 in the middle here, the next nearest 5 is 2,405. And the nearest 5 below is 2,395. Now again, this is about the bounds, so it's in between these two. So this is the one scenario where there is no real little trick here, but if we think about halfway between those, halfway between a distance of 5 is 2.5. So if I was to add 2.5 onto 2,400 to get this one, I'd get, and it's not the nicest little decimal here, we get 2,402.5, adding 2.5 on, and if we take 5 away, let's just write plus 2.5 there and minus 2.5 here. If we take 5 away, and it's not the nicest one, it's 2,397.5 on the one below. So there's no little trick for this one, it's just adding 2.5 on and taking 2.5 away to find the upper and lower bound. But once you've got your head around that, when it's to the nearest 5, this is obviously just one of your harder scenarios here. So in terms of writing it out, we've got 2,400, everything else is exactly the same. But we have 2,402.5 on the one above, and on the upper bound, sorry, and 2,397.5 for our lower bound there, and that's our final answer. So this is just one of our unique scenarios. All the rest were the same, but we've got one unique scenario here when we round into the nearest 5. Let's have a look at one more. Okay, so the speed of a car is 60 miles an hour correct to the nearest 5. Write down the error interval for the speed of the car. So it's the same process again. When it's the nearest 5, that means it could be 2.5 above or 2.5 below. So if we've got 60 in the middle, nice and simple. Once you've got your head round it, you add 2.5 on for the upper bound, so 62.5, and take 2.5 off for the lower bound, so 57.5 for the one below. And again, there's our error interval. Okay, so just thinking when it's to the nearest 5, it's just add 2.5, half of that, and when it's for the lower bound, it's minus 2.5. Okay, you've got to be very, very careful with the numbers there. Right, here's a couple for you to have a go at, just something slightly different to finish on. Okay, so here's 2 questions. Have a go, pause the video there, I'll go over the answer in a sec. Okay, so the first one, we've got 45 as the speed of the car, and again you can put X or the number in the middle or any letter actually, but let's just go for it. So add 2.5 on gives us 47.5, take 2.5 off gives us 42.5, and there we go, there's the answer for the first one. On to the next one, we've got 3,500 correct to the nearest 5, so 3,500 in the middle, and again it's just adding 2.5 on, so 3,502.5, and on the lower one 3,497.5. There you go, you just got to be a little bit careful with those ones, and there's our final answer. Right, now before we finish, because that is basically all of upper and lower bounds there with when we're looking at error intervals, but there's one other quite unique scenario that is very different to these, and it's got different wording that I just thought we'd just have a look at just to finish. Okay, so we're going to have a look at that one now. Okay, so this says Alice works out a sum on her calculator. She writes down the first 2 digits on a calculator display. She writes down 7.4, write down the error interval for Alice's answer. Now this is not about rounding. It doesn't say she's rounded it to 1 decimal place or 2 significant figures. It just says she writes down the first 2 digits. Okay, and this is something completely different. When you just write down the first 2 digits and don't do any rounding, it's called truncation. So it might have said Alice truncated her number to 2 decimal place, two digits, sorry. And all that means is she's basically just completely disregarded anything else on a calculator display. And that means that this number here, 7.4, is definitely on her calculator. Okay, so there is no other digit that could be there other than those 2, because all she's done is she's looked at the first 2 and written them down and completely disregarded mathematical rounding. Okay, and it's called truncation. Now when we have to write an error interval for this, it's actually quite simple, but it's just something you need to get your head around. Okay, everything's written in the same way. We've got a letter or a number in the middle, and our arrows are still pointing to the left with our equal to symbol on the left. Now because 7.4 has to be on our calculator display, it does say that she definitely wrote that down, that's what she wrote down, then 7.4 is our lower bound. It can't have been anything lower than that, because that is what's on her calculator display. In terms of the upper bound, the number that it can't be is the next number up from the number at the end there. So 7.4, now it couldn't have been 7.5. Okay, if it said 7.5, she would have written down 7.5 and not 7.4. So the upper bound is 7.5. Okay, and that is truncation. Okay, all you do is you put that number as the lower bound and the next number up as the upper bound. So I could always give you a couple to have a go here, because it is slightly different, but it's actually quite simple once you get your head around it. Okay, in terms of you just write down the number that you're given as the lower bound and the next number up as the upper bound. So you could have a go at 2 here. If I just give you this one, look, this number here, let's go with 2.8, was truncated to 1 decimal place, and I could even have a go at this one here. Let's just say the number 7 was written or truncated. So here we wrote down the first 2 numbers on the calculator, here we wrote down the first number on the calculator. So there you go, you can always pause the video there, have a go, and I'll go over the answers. Okay, so something slightly different. So 2.8, if this has been truncated, and again we can put 2.8 in the middle, but the lowest it could have been is 2.8, and the next number up would be 2.9. And then for the 7, again the lowest number it could have been on the calculator is 7, but it can't have been 8. Okay, so just a last little thing to be thinking about there. It's not really to do with rounding, it is truncating, but these little questions on truncation tend to be popping up on the exams as little 1 or 2 markers, and it's just something to be thinking about. If it doesn't say rounded and it says she wrote it down or truncated it, or these were the first 2 digits or the first 1 digit, okay, that's just something to be thinking about slightly different there, thinking about testing your logic on the concept of numbers. But there we go, that is error intervals and rounding with bounds. So hopefully you found that useful. If you found it helpful, please like, please comment, please subscribe. I'll see you for the next one.